Now it's time to put everything we have learned about the DOM into practice by building a real application. This way, you will get hands-on experience similar to working on an actual project. We are going to build an expense tracker application. The purpose of this app is to keep track of our daily income and expenses. If you look at the UI, on the left side, there's a form called Add New Transaction. Inside this form, you will find a few input fields: type, amount, date, and category. By filling out this form, we can create a new entry for either income or expense. Above the Add New Transaction form, there's a balance summary section. Here, we can see the total balance, the total income, and the total expense. In other words, a quick summary of everything in one place. On the right side, there's the transaction history section. Items or rows with green icons represent income, meaning money has been added to the account. Rows with red icons represent expenses, meaning money has been spent. If you compare this with the Add New Transaction form, you will notice that the type field in the form lets us choose between income or expense. That same choice is reflected in the transaction history, where the green or red icon appears based on the selected type. The amount field also directly shows up in the transaction history. If it's an expense, the amount appears in red. If it's income, it appears in green. At the same time, that amount updates the balance summary so everything stays in sync. The form also has a date field, and that date is displayed directly in the transaction history. Finally, there's the category field, where we specify which source the income or expense belongs to. For example, for income, we might write salary or profit, and for expenses, we could write rent or electricity. At the very end, each transaction has a small cross button. Clicking on it removes that transaction. Notice that as soon as you delete one, it disappears from the transaction history. And at the same time, the balance summary updates instantly. If you delete multiple items, both sections adjust right away. So this is our project, a very simple CRUD application. Here, we are creating new transactions, reading and displaying them in the transaction history, and also deleting them if we want. The whole process is simple and straightforward. Now, if we talk about the technical flow, the first thing we will do is listen to the form's submit event. Whenever someone submits the form, a new transaction item will be added instantly to the transaction history. At the same time, the balance summary will update with the new values. So, let's dive into the code. First, we will open our script.js file. According to our plan, the very first step is to define some variables. First, open the index.html file. Inside it, you will find the form element. And notice that this form has an ID called transaction form. Since we need to listen for the form's submit event, the first step is to grab a reference to it. To do that, we will write const transaction_form is equal to document.getElementById transaction form. Here, we are simply selecting the form element by its ID, which is set to transaction form. Next, when the user submits the form, we will take their input and display it in the transaction history section as a new list item. To do that, we need a reference to the parent element, which is the UL. So, we will write const transaction_list is equal to document.getElementById in the bracket transaction list. If you open the index.html file, you will see that the UL element already has this ID, transaction list. Now, along with displaying the new transaction in the transaction history, we also need to update the balance summary. If we check index.html, we will see that in the balance summary section, the element showing total balance has the ID total balance. The element for total income has the ID total income, and the element for total expense has the ID total expense. So, inside our script.js file, we will create references for this as well. We will write const total_balance is equal to document.getElementById in the bracket total balance. Then, const total_income is equal to document.getElementById in the bracket total income. And finally, const total_expense is equal to document.getElementById in the bracket total expense. That way, we now have all the references we need. I hope this part is clear. Our next step is to listen for the form's submit event so that whenever someone submits the form, we can create a new transaction item. Let's do it exactly the way we practiced in the previous lesson. Here, we will write transaction_form dot add event listener. Which event should we listen to? Since we want to capture the form input values when it's submitted, we will listen for the submit event. So the syntax will be transaction_form.add event listener. In the bracket, in the first parameter, we will write submit, and the second parameter, we will write a function, and which can take an event as a parameter. This callback function receives the event parameter, and inside that we can access the form, its target elements and their values. Inside the callback, the very first thing we will write is event.preventDefault. Remember from the earlier lesson, by default, when a form is submitted, the page reloads. But we don't want the page to reload on submission. That's why we use preventDefault to stop that behavior. Keep in mind, preventDefault isn't limited to forms. It can block the default behavior of any element. For example, if you apply it on an input field, you will no longer see the typed text appearing there. Now, let's test whether our form is actually being submitted. We will write console.log in the bracket hello world. Save script.js, reload the page in the browser, and submit the form by clicking the Add Transaction button. You will see hello world printed in the console, which means everything is working as expected. Next, instead of logging that message, we will extract the values of the input fields using event.target. For example, we will write const type is equal to event.target.type.value. Here, event.target refers to the form, and from inside it, we are accessing type.value and storing it in a variable called type. You might be wondering, how did we get the type property inside event.target? To understand that, let's go back to the index.html file. There you will see that inside the form, we have a select option element. As you already know, select option tags are used in HTML to create drop-down menus. And we also have one in our UI. If you look closely, you will notice that this element has a name attribute and its value is type. That's why when we access event.target.type, it works perfectly because event.target looks at the form's fields by their name attributes. In the same way, if we want to get the value from the next input field, amount, we will use event.target.amount.value. This logic applies to all the fields in the form. So let's go ahead and add those inside our script.js file. Right under the type variable, we will write const amount is equal to event.target.amount.value. With this, we are able to fetch the value entered in the amount field. Next, for the date field, we will write const date is equal to event.target.date.value. And finally, for the category field, const category is equal to event.target.category.value. That way, we now have references to all our input field values. To make sure everything is working, let's quickly verify in the browser. At the bottom of the code, we will add console.log type, amount, date, category. Then save the file, reload the browser, fill in some data in the form, and click the Add Transaction button. If you check the console, you will see all the entered values printed correctly. That confirms everything is working as expected. Now our task is to insert a brand new item inside transaction_list. For that, we will write a separate function whose job will be to take the values submitted by the user and build a new list item out of them. Let's write that function. Just above transaction_form.addEventListener, we will add function updateList. This updateList function will receive type, amount, date, and category as parameters. For now, we haven't called updateList yet, but later, inside the form's submit callback, we will call it and pass the input values as arguments. Simple. Inside updateList, we will use document.createElement to create a set of new elements. But which ones do we need? Before writing the code, we need to understand the role of updateList function. The job of updateList is to add a new li element inside the transaction history section's UL. That li will contain all the details of the user's submitted data. If you open index.html and look inside the transaction list UL, you will see what a transaction item looks like. Each item is an li with the class transaction-item. And inside it, there are several nested div elements. That's exactly what we will rebuild using JavaScript. So inside updateList, we will start with const item el, that means item element in short, is equal to document.createElement in the bracket li, since we first need to create the li element. Then for the icon, we will add const icon el is equal to document.createElement and in the bracket div. Next, we check index.html again. We will notice that we also need a transaction-details div, and inside that, two more divs, one for transaction-name and one for the date. So we will create those two. Const details el is equal to document.createElement in the bracket div. Const name element is equal to document.createElement in the bracket div, and const date el similarly. Here you will notice a small convention. Item el, details el, name el, date el all have el at the end. This is just for clarity to remind us that these are DOM elements. It's not required, but it helps keep the code easy to read and understand. You can say it's just a best practice. We still need to create a couple more elements. If you check index.html again, you will see each transaction also has a transaction-amount element along with a transaction-delete button. So we will build those two. Inside script.js, we will write const amount el is equal to document.createElement in the bracket div, and const delete el is equal to document.createElement in the bracket button. Since we are making a button, we specially pass button into createElement for delete el. That part should be clear. Now you might be wondering, why did we create a separate update list function at all? Couldn't we have just written the element creation code directly inside the submit callback? And honestly, that's a very good question. But here's the reasoning. Yes, we could have written all the document.createElement logic directly in the submit callback. But the reason we don't is because we want our code to remain clean, readable, and maintainable. By splitting things into separate functions or modules, the code becomes much easier to read, understand, and modify later on. Think of it like this. In your kitchen, you have all sorts of jars and spices. You could keep them on your computer desk if you wanted. It wouldn't technically break anything, but we all know that's not the right place. The computer desk is meant for working, not storing spices. In the same way, the job of the submit callback is to handle the form data, not to worry about rendering the UI. That's why we have created a separate function whose sole purpose is rendering the UI. The submit callback will just call that function and let it handle everything else. So, update list is dedicated to rendering and the submit handler is dedicated to managing the form input. This separation keeps everything neat and organized. I hope that clears things up. And if you still have confusion, you can always post on our Logic-based Labs page and tag us. We will do our best to help solve your issue. Alright, let's get back to the actual work. Inside the update list function, the next step is to add classes to each DOM element we have created, just like they are defined in our HTML. Along with that, we will also set the values coming from the parameters. First, for item.el, we will add the class transaction-item because this class ensures it gets the right styling. So, we will write item.el is equal to classList.add in the bracket transaction-item. Here, we are using a new property called classList, right? Earlier, in a previous lesson, I showed you another way to add classes. And yes, that method still works. But classList.add is the cleaner, more standard approach. So this is what we will use going forward. Now, let's add the remaining classes following our HTML structure. For the icon element, we will write icon.el.classList.add in the bracket transaction-icon. Then detailsel.classList.add in the bracket transaction-details. Next, nameel.classList.add in the bracket transaction-name. For the date element, we will add dateel.classList.add in the bracket transaction-date. For the amount element, we will use amountel.classList.add in the bracket transaction-amount. And finally, for the delete button, we will write deletel.classList.add in the bracket transaction-delete. If you want, you can open index.html and cross-check each class name side by side to make sure everything matches. Now that the classes are in place, the next step is to set the actual content. First, let's set up the icon. Which icons do we need? If we look at the browser, you will notice that green circles have an upward arrow, while red circles have a downward arrow. That means we need to add them conditionally. So, in our code, we will set icon.innerText. You already know how inner text works. We covered it in an earlier lesson. Now we will check if the type is income, we will display an up arrow, otherwise a down arrow. Using the ternary operator, that becomes icon.innerText is equal to type triple equal to income question mark upper arrow colon down arrow. A simple if-else logic written in a compact way. Next, we will conditionally add a class to icon.el. If the type is income, we will add the income class. If it's expense, we will add the expense class. So, we will write icon.el.classlist.add in the bracket type triple equal to income question mark income colon expense. This is exactly how it was in the HTML, where transaction-icon had either income or expense as an additional class. After that, we'll set the name EL content. Since this comes directly from the category field, we will write name element dot inner text is equal to category. Now for the date, we will set dateEL.innerText to a formatted date using JavaScript's date object. So dateEL.innerText is equal to new date in the bracket, the date parameter, dot toLocal date string. The first parameter will have a string, en-us. Then an object with these key value pairs, month, short, day, numeric, and year, numeric. This way, the date appears in a neat, natural format like, for example, October 27, 2025. Date is a built-in JavaScript feature with lots of methods. And yes, sometimes it can be confusing. That's why we have created a date methods cheat sheet on the Logic Based Labs page. It's a handy reference for situations like this. Next, we will handle the amount. For amountEL.innerText, we will conditionally add a plus or minus sign based on the type. If it's income, we prefix with plus, otherwise minus. Then we add a $sign and the amount. So the code looks like this. amountEL.innerText is equal to if type is equal to income, then plus, else minus. Then we can concatenate with a $sign and then an amount. After that, we will also add a class to amountEL, just like with the icon. Income items get the income class and expenses get the expense class, so that the text color is styled differently. If you open index.html, you can see that the div with transaction-amount class also has income class. So we are logically adding that income and expense classes. There's one last step left. We will set a cross symbol as the inner text of the delete button. For that, we will write deleteEL.innerText is equal to a cross. That means we can write X. Now, all that's left is to append these elements together, making sure the parent-child relationships are followed exactly as in the HTML. If we open index.html and look inside a transaction-item, we will see the structure clearly. First comes the icon, then its siblings, transaction-details, transaction-amount, and the transaction-delete button. Inside transaction-details, there are two children, transaction-name and transaction-date. We need to recreate this exact structure in our DOM. So first, we will append the children into details.el. details.appendChild in the bracket nameEL. Similarly, details.appendChild dateEL. Now we will assemble the full item step by step. itemEL.appendChild in the bracket iconEL. Then itemEL.appendChild in the bracket details.el. Similarly, itemEL.appendChild amountEL and itemEL.appendChild deleteEL. At this point, itemEL represents a complete row, exactly like a transaction in our history. The first step is to place this row into the transaction history. For that, we will use transaction_list.prepend and in the bracket itemEL. Remember, prepend works just like append or appendChild, but with one difference. Append adds new elements at the end of the list, while prepend adds them right at the beginning. So now you have seen the full flow. But will this work if we submit the form right now? Not yet, because so far we have only written the logic for creating elements. We haven't actually called update list anywhere. And when we call it, we also need to pass the form input values as parameters. So let's go ahead and do that. Inside the form submit callback, we have now called the update list function and passed the arguments in the correct order: type, amount, date, and category. Everything looks good so far. So let's test it in the browser. We enter some values in the form. Then click Add Transaction, and there it is. A brand new transaction row shows up immediately. Now let's try adding some expense data. Perfect. The expense is added too. Notice how the expense shows a red icon, while the income shows a green icon. Congratulations, we have made solid progress. There's just one small thing to fix. In index.html, we still have those hard-coded transaction-item examples. We should remove them because we only want our transaction history list to show dynamically created items. Another detail to notice: after we add a new transaction, the form fields still keep the old values. For a better user experience, the form should reset after submission. To do that, right after the line where we call update list, we will add transaction_form.reset function. The reset method is specifically for forms and it clears all the fields instantly. Simple JavaScript. Let's try again. We add a new transaction. This time, as soon as the form is submitted, it resets itself. Perfect. Now, we still have one important task left: calculating the balance summary and updating it dynamically. And for that, we have two possible approaches. Exactly. In the first approach, we would have directly read the current values of total_balance, total_income, and total_expense using inner text or text content. Then adjusted them whenever the form was submitted. But as we discussed, this is risky because if someone manually edits those values from the browser's dev tools, all our calculations would go wrong. That's why the second approach is much safer and more reliable. Here, we will maintain a proper array of all transactions, and every calculation will be based on that array instead of what's currently displayed on the screen. So first, at the very top of our script.js, we define an array. Let all_transactions is equal to a blank array. Then, inside the submit callback, right after we call update list, we will save the form input data into this array. We will store it as an object. all_transactions dot unshift, and in the bracket type, amount, date, category. We are using unshift here because we want the most recent transaction at the start of the array. Remember, push would add to the end, but unshift adds to the beginning. Now, all our transactions are stored in the all_transactions array as objects. With this in place, we can move on to writing our calculation logic. For that, we will create a function called updateBalance. Function updateBalance. Inside this function, we will first declare three variables: income, expense, and balance, and initialize them to 0. Let income is equal to 0, let expense is equal to 0, and let balance is equal to 0. Next, we will loop through the all_transactions array using for each. All_transactions dot for each. We will get each transaction as transaction, and in the callback function, we will return something. Here, transaction refers to a single object from the array containing type, amount, date, and category. That means for every iteration, we will have direct access to transaction.type and transaction.amount, which we can then use for our calculations. Now the question is, how do we update income, expense, and balance inside this loop? Now we will use an if-else condition to check the type property of each transaction object. If the type is income, then we will add the transaction amount to both the local income variable and the balance variable. If it's not an income, meaning it's an expense, then we will add the amount to the expense variable and subtract it from the balance. So here's what we do. Inside the if condition, we check transaction.type is equal to income. Then within the curly braces, we write income plus is equal to parse float in the bracket transaction.amount, and right after that, balance plus is equal to parse float in the bracket transaction.amount. Notice here, I have written income with a capital I. That's because from the select option element, the value we will get is income with a capital I. Since JavaScript is case sensitive, we have to write it exactly the same way. Also, I have wrapped transaction.amount with the parse float method. That's because whenever we fetch a value from the DOM, it always comes back as a string. And if you add a string to a number, instead of doing a proper calculation, JavaScript will just concatenate them together. To avoid that, we use parse float so the string is converted into a number before adding it up. In the else clause, we write expense plus is equal to parse float in the bracket transaction.amount, and balance minus is equal to parse float in the bracket transaction.amount. This way, when the for each loop finishes, we will have the actual calculated data for income, expense, and balance. The only thing left is to update those values in the DOM. Since we already have references to total balance, total income, and total expense, we can simply update them using inner text. We write total_balance dot inner text is equal to a $sign and then plus balance. Here we have added a $sign before the balance just to make it look nicer. Then we write total_income dot inner text is equal to $ plus income. And finally, total_expense dot inner text is equal to $ plus expense. The last step is to call the update balance function. So inside the submit event callback, we call update balance right after storing the transaction. We don't need to pass any arguments while calling it because all the variables this function needs are already in the global scope, so it can access them directly. Now, let's go back to the browser, reload the page, and start entering some data. First, I selected type as income, entered 1000 as the amount, picked a random date, and wrote salary in the category field. Then I clicked on the Add Transaction button. Notice how a new item instantly appeared on the right side. And on the left side, the balance summary updated correctly. In the same way, I added another expense entry. This time, I entered 50 as the amount, wrote rent in the category field, and submitted it. See that? Everything is working perfectly. The balance summary updated just as expected. So far, everything is working just the way it should. But there's one small improvement we can make. Try refreshing the page again. In the balance summary section, we will notice it's still showing some hard-coded values from our HTML. To make it look more authentic, we can reset those values to 0 instead of keeping the preset numbers. So, open the index.html file, then go to the balance summary section, update the total balance value to 0. And in the same way, set both the total income and total expense values to 0 as well. Now there's one more feature left to build, the delete option. Let's work on that. For this, we will go back to the update list function. If you look there, we already created a delete button called delete EL. What we want now is that whenever someone clicks on delete EL, that specific transaction item gets removed. To make that happen, we will need an event listener. Inside the update list function, we will attach a click event listener to the delete button by writing deletel.addEventListener in the bracket, first parameter click, comma, delete transaction. Here, the callback for the click event is a function named delete transaction. That means whenever the delete button is clicked, the delete transaction function will run, and this function will handle how the transaction is actually removed. We haven't written the delete transaction function yet, right? So outside the update list function, we will define it as function delete transaction. Since delete transaction is called from the click event listener, it will receive the event object. So inside the delete transaction, we will have access to that event. Now the question is, how will delete transaction actually work? How do we remove the item? Since we have both delete transaction and the event object, we can use event.currentTarget to access the delete button itself. From that button element, we can use the closest function to get a reference to its parent transaction-item element. Then, by simply calling remove on that item, we can directly delete the entire transaction from the DOM. So, inside delete transaction, we will write const btn, that means button, is equal to event.currentTarget. That gives us the button. Then we will get the parent list item by writing const itemel is equal to btn.closest in the bracket dot transaction hyphen item. Now itemel is the li element of the transaction where the user clicked the delete button. To remove it from the DOM, we just call itemel.remove function. Let's save the file and test this in the browser. We add a few transactions and click the delete button. See, the transaction is deleted cleanly. If we delete another one, it works the same way. Every time we click the delete button, the corresponding transaction disappears. But there's still a problem. The balance summary is not updating. So the next question is, how can we fix that? If we think about it, in order to update the balance, we also need to remove that specific transaction from the all_transactions array, right? The challenge is, when we delete an item from the list, how do we know which element in all_transactions it corresponds to? To solve this, we will get the index of the deleted item from inside transaction_list. Once we have that index, we can remove the same transaction from the all_transactions array. Let's do that. Inside delete transaction, after we use btn.closest to get itemel, we will calculate its index like this. Const index is equal to array.from in the bracket transaction_list.children, and then the index of item element. Here we are using array.from to convert all the children of transaction_list into an array. Since we now have an array, we can easily use index of to find the position of itemel. That means we can directly get the index of the row we are deleting without any hassle. I am not going into detail about array.from or index of here, since I am assuming you already know how these work. Using the index we just found, we will remove the corresponding object from all_transactions with splice. All_transactions.splice in the bracket, the index, comma, and the second parameter 1. This deletes the targeted transaction from the array. Right after that, we will call updateBalance function. That function will recalculate everything using the updated all_transactions array and refresh the balance summary accordingly. So let's test it now and see if everything is working properly or not. I have already added a few transactions to the transaction history. Now let's start removing them one by one. Notice how every time I remove an item, the balance summary updates immediately. And if I delete all of them, the total expense resets to 0. While total income and total balance adjust correctly to match. This means our program is working exactly as intended. Congratulations! Step by step, we have built and completed our expense tracker app using the DOM. Of course, this can be improved further. For example, right now if you submit the form without entering any data, it still accepts it. And if you click delete, the transaction disappears instantly. But the proper way would be to validate the inputs before submission and to ask for confirmation before deleting. Also, if you reload the page, all the transactions are gone. You could enhance this by saving them in local storage so that they remain even after a reload. These are exactly the kinds of tasks you will take on to improve the user experience. And they all fall under basic JavaScript. I hope by now you clearly understand how important the DOM really is. Even for such a small app, you can see how beautifully everything comes together with Vanilla JavaScript. And just like this, we can perform all kinds of functional operations using the DOM. By working on this project, you have already seen practical use of many DOM elements. Since I work with the DOM regularly, I was able to pick them up quickly and explain them to you in a simple way. So, if you practice a little, you will also be able to pick these things up very quickly. For example, the prepend method came to my mind while working, so I showed it up here. Then there's the remove function. Since we already have append, it makes sense that remove would exist too. Similarly, there's another function called remove child, which directly removes an element from the DOM. In this way, we picked up a few new things along the way. Hopefully, by now, your fear of working with the DOM has gone away. I have tried to cover just about everything. At the beginning, I showed you how to select different DOM elements, then how to traverse them, and how to handle parent-child relationships using simple methods. I also showed you how to create new elements, add children, remove them, select elements in different ways, and listen for various DOM events. These are the things we used most often in our daily work. And the best part is, we did all of this with plain vanilla JavaScript without using jQuery or any other library. Although in the past, most people would rely on jQuery for these small tasks, now you can see how easily it can all be done with JavaScript itself. So that was my complete course on the DOM. I'm wrapping up this video lesson here. At the very beginning, I promised to share some project ideas with you. At the end, after practicing this project, you can try building a few more simple applications like a calculator, a to-do application, a form validator, or even a weather app. Make sure to maintain CRUD functionality so that create, read, update, and delete all work properly in your applications. Also keep your apps responsive so they run smoothly on different web and mobile devices with JavaScript. If you want even more project ideas, you can follow our Logic-Based Labs page. We regularly share different cheat sheets, project ideas, and tech-related resources there. And if you get stuck while working on a project, don't hesitate to mention our Logic-Based Labs page and post your code along with the problem details. We will do our best to help you out quickly. You will find the link to the page in the video description. Before I end, just one small request. If you found this video series helpful or learned something new, please let me know in the comments. And if you would like me to create more detailed videos like this, suggest some topics and I will try to explain them in the simplest way possible. Finally, if you enjoyed my content, don't forget to subscribe to our Logic-Based Labs YouTube channel and follow us in social media. All the links are given in the video description. Thanks for watching this video all the way through. See you again in another one. Signing out.